So the plan for today is to try out the Ziglings. This mainly is because I saw some comments on the compiler video in Zig that it was, I was trying to code like it was in C, and that's not really the way of doing it. And I know I said that Ziglings is not for the chats, but it is what it is. So yeah, I'm gonna try out Ziglings. The only issue that I have was that my Zig version, I don't know, it's like Enums. For some reason it's not the latest one. So instead of waiting for, I was trying to get, I think, Zig Git or something, but it complains about LLVM or some stuff like that. And yeah, I'm not gonna wait to compile from source, so I just downloaded the latest release and I'm gonna use it like this instead of calling to Zig. So hopefully that's gonna be fine. So yeah, like the first step it says here is to clone the repo. I also link to this thing. I saw that this is the official one, so yeah, let's see. So this is how you clone it. Then I opened the tmax session in this folder, and now it says to run build and to follow the steps, right? So from what I understand, Ziglings is like Rustlings, which I think I did like 3 or 4 years ago, so I don't remember what this was, but it was like exercises. So let's see, I guess there are gonna be small bugs or stuff like that in each file that we need to fix. Oh, don't panic. So I guess the first step is to try and understand how the error messages work in Zig, because I know from experience that in Rust it took me a while to figure it out. Like I was really used to the C error messages, which are really useless sometimes. So let's see, like let's compare to Rust, because in my opinion Rust error messages are really, I guess let's try to compare to the Rust ones, because yeah, I really want to understand why the hype for Zig exists, because for now I cannot really figure out why someone with, let's say, 20 years of experience in C would switch to Zig. I don't think that's gonna happen, and I want to be proven otherwise, because if like memory safety is the only reason, then I wouldn't do it. And even standard library, it's like, okay, you have array lists, you have vectors, you have strings, you have all of that good stuff in Zig, but I'm pretty sure someone with a lot of C experience already has their own standard library for that. So that's not really something I would see someone just switching to Zig. And yeah, let's go to the exercises folder. Let's see. So first of all, it says, this is a pretty good error message. I don't even need to read the code. I can just know that this needs to be pub or what, I guess. Well, it was not a good error message then. Like that's what I would understand from this. Okay, let's see. Wait, what? So weird. Maybe I didn't save. We have to watch the replay. Like we have to replay that. Okay, anyway. So let's go to the second one and let's see what it says. Oh, I'm pretty sure. Let's see. So it says we need to replace the question marks, obviously. The comment already gives Okay, so it's like const std. That's pretty easy. I guess these are not really 03. Alright, so one of, oh yeah, I guess this one makes sense because here n is const, but we change it. So but I guess fixing this one we should use var. I mean, you know, already know some things because tried Zig already, but so I know that you can use var to declare immutable variables. That's okay. And here u8, I guess it's not enough for this kind of number. So here it already tells us u8 can hold this kind of numbers. Okay, so maybe u32, right? Like, I mean, it can hold even larger numbers, but that's and this can be an i8. But yeah, pretty cool printing. I mean, it's like Rust. Wouldn't say that's okay. So still got this one, both of them. I guess I can use this 00. Okay, yeah. So for this one, okay, so the fourth one, I mean, you know, since it's a really good language, like a normal one, we can use 3 for this thing. Oh, so len is a property. I mean, it makes sense because it's like some primes is an array, so len is something on the array. Okay, pretty nice. That's something, you know, to keep in mind. Interesting. The 004. Oh, so I guess if you declare this thing as a const, you cannot assign to it. So individual values can be set with this thing. But you know, as a TypeScript they would say, you know, this one is const. In TypeScript, when you have const for an array, you cannot change the reference, but you can change the values, which is pretty sus, not gonna lie. Okay, you know, makes sense. So the next one, arrays 2. Arrays 2. Set this array concatenating the two arrays. Oh, can we say le plus et? That would be pretty awesome if you can add arrays like this. Okay. Oh, nice that you can do this thing like in Python, if you know, but it's not, yeah, it's not really like in Python, right? Like if I would do something like 1 2 3, well, actually it is just like Python. Pretty nice. You know, I'm not sure. Let's try to do it like this. Oh, it complains about the, so you still have to solve everything. I'm curious if plus works. That would be pretty interesting. I mean, you know, I haven't... Oh, so 2 pluses. Now, actually makes sense to use 2 pluses. Like in Haskell. If you... So, plus plus and multiply, star star. Okay. Are for arrays. While your program is being compiled? Oh, so it's only for... interesting. For like const. Probably. Okay, let's see. Now maybe you should read all of this. But you know, whatever. It's like, okay, this one is interesting though, that it's executed at compile time. But then it means that most of the times you won't even be able to use them, because like, when do you need this kind of stuff, right? Pretty rare to happen. I mean, this one, initializing an array like this, happens quite often in you know, initializing an array with all zeros or all ones, for example. That can happen, but this one not really. Okay, whatever. So this one, okay, I mean, to get the letter D is pretty simple. We just say 0, 1, 2, 3, 4, right? Pretty cool that it works on strings too. And probably concatenating. I mean, yeah, for strings maybe I can see it being useful, but for arrays maybe not. Okay. You know, in C you can do this, but that's... Oh. Wait, I'm... it wants a space. Didn't notice. Okay. Multi-line strings. I really don't know how I feel about this one. Yo, actually this one is pretty cool, because like it happens really, especially in Python, when you create multi-line strings, right, and you want to format them nicely. You know, this is a pretty good feature. It would be nice to have in other languages as well, like, because usually multi-line strings, you put like a backslash at the end of the line, but you don't have a place where it starts, right? So you have all this white space, and you would have to do something like this, which is kind of ugly. But this one is pretty cool. Oh. Actually, yeah. But again, you know, but yeah, it's a pretty cool feature, yeah, not gonna lie. But wouldn't be, you know, enough for someone to make them convert from C to Zig, like. But would be nice to have in other languages, yeah, obviously. Okay, so this one is like what? Quiz. Oh, so it's like, let's see if we can get it first try. Okay, so quiz time. Okay, let's see what the compiler says. Well, I mean, it's okay, so I have to do something like, 0 is, so probably I have to say 1 here. And here I have to say x, obviously. And which one is g? So 0, 1, 2, 3, 4, 5. Now I know how to count. Sure. Watch it not being programming Zig and being like programming Zilla. Damn it. Well, if it is a compile error, we can consider it as being first try still. So we need to make it var. Okay. I'm curious, does usize have the same meaning as... Okay, yeah, it actually does. Yeah, we got it. First quiz. Oh, so now we get into if territory. Okay. Obviously this one... It's like 1, like this. Oh, this one is actually... Well, you know, in some way I would prefer this instead of variadix, or what's it called when you have, you know, like in C when you have multiple arguments, like k args in Python. Honestly, I prefer it to be like this, even though you have to type something extra even when you do just a print. I mean, it's still better because it's easier to understand what happens. Okay, so 0, 10. Oh, so this is how you do it. Because yeah, in the compiler one, I wanted to find a way to have like if expressions, but I couldn't get them to work. So let's see. If this count, then 17, else 20. So is it like this? It wants parentheses. Oh yeah. Oh, so without the then. Okay, okay. Perfect. So this is how you do. I mean, okay. Does it also work with Does it still work? Do I have to say return? Like, I want to know how I can have, you know, more complicated. That's like more interesting, how to have more complicated if expressions, because like this one maybe we'll see in the next problem or something, because that's what I need more, like how to write ifs and whiles, you know, pretty self-explanatory, but until okay, so n, oh my god, I'm gonna make a fool of myself. Okay, so well, I would say while it's smaller, it's more safe that way. wait, oh, so next one, 0, 12. Oh, oh, this one is continue expression. Oh, this one is like a new one. But I don't know what we want to print. Wait, what do we want to print? Let's do n+1. I don't know what's... But I don't know what's the desired. Whatever. Let's see what the... Whoops. Oh, so it's multiplied by 2, okay. I wasn't really sure what it wanted. So I can write it like this or like this. Either one works. Okay, cool. I mean, I like this one. But, like, why not just use a for loop? Whatever. 0, 13. Wait. 0, 13. Oh, so this one is fizzbuzz, I can see. Right? I mean, it's kind of continue. Huh. I mean, yeah, continue works just like in C. Okay. So the next one is 0, 14. Oh dear. Oh. Okay, so if n is equal to 4, we can break. Pretty sure. I mean, pretty sure that break is a thing. Okay, so I mean it is. Okay. Oh. I mean, I know I was just looking. Okay, I mean, yeah, this one is pretty. So for you know, story, I guess. Scene. For things called slices. Interesting. I mean, probably slices is something similar to a slice in Rust. So for loops like this are gonna be similar to iterators, right? I mean, that's what I guess. Let's see. Okay, cool. Wait, it's like happy, sad, neutral. Okay. 0, 16. Okay, so you can do like a zip, right? So here I want to show like, okay, so it's like powers, right? I mean, it's gonna be clearly like 0 dot dot, and this is the I, right? So this is a built-in function. To cast an int. Because this is a new size. But can you do like... No, you cannot. Or like this? No. You cannot change the type of what you get here, I guess. Whatever. Oh, so it's like this exercise is really old and the new Zig language has more features for for loops. Okay. I mean, let's see. Oh no, I already forgot. I mean, I'm just kidding. It was... Okay, Fizzbuzz time, holy. So it was like this, right? std. This one is pubfn. While loop. Easy. And I mean, if I... You know, the classic. I guess here we want to print I. Let's see, first try. First try, I guess, yeah. Function. I mean, yeah, to be honest, these one are pretty easy, but also don't want to skip them, would be kind of weird. One thing we're not missing is the keyword pub. Yeah, I mean, it's, you know, it's not needed because it's the same file, I guess, but... So deep thought. Oh, so it's like U8. It returns U8 because, yeah. Yeah, as I said, pretty self-explanatory for these ones. To the... So this one is like the power, right? I mean, let's see what power needs. Also, it works for anything as long as we have... Oh, I mean, now comes the... I mean, you know, the cool part, right? That you can have like generic functions and the generic type is actually an argument. Like how it would make more sense. Honestly, like the way Zig does it, I think makes more sense than how other languages do it. Like it makes it more obvious what happens, even for a noob, right? They see, oh, so the function takes in a type. It's not like what does this thing mean? Like what the fuck is this, right? This maybe confuses people. So it's an U32 my number. Yeah, I mean, let's see. Another quiz so quickly. So print the powers of 2. Yo, what? I mean, this one needs to be a 4. It looks like this one is a void, right? Interesting. I mean, this is a while loop. We kind of want to return total, I would say. And I think it's U16 because, you know, that's the type of total. So we get U16. I mean, it doesn't matter. Should work, I would say. Ooh, errors. No, because I wanted to get into errors. That's more like cooler, let's say. Too big, too 4. Oh, it's too much of a 4. Too small. Okay. Nice. I mean, the fact that we have errors as values, I mean, I'm gonna say it like all languages need to have this one. Like it's not even something new anymore. It's like pretty much required if you want to have a good language. Like, let's be real, the fact that Python, JavaScript, all of these languages still work with try catch, it's insane. Okay, my number, clearly the number. Oh, can we have interesting. I was gonna say if it's like an union, but it's a result type. So it's like my number. Initially I would say it's U32, but it wouldn't work because then we assign this thing to it. So we need to do it like this, like the union. And yeah, this is the first thing I would say I didn't really like at first, because it is a bit strange. Like it's maybe more but again, I don't know if it would work. Like the result type, how it's in Rust, it makes it more clear. Like you notice, like this is like similar to the thing that I said that try is better than question mark in Rust, because a single symbol you cannot really see it when you glance at the code, but result type like this is much more visible than the exclamation point or the question mark, so it like did a good change with try, and then it did a bad, I mean, I won't say it's a bad change, but whatever. Oh, catch. So I mean, I just have to rewrite that. Okay, and for the return is like my number error or U32. But again, like I really think that result type, literally writing down result was better, but whatever. $0.24, okay. Oh dear, this no, it's missing a lot. So I guess detect problems, it returns something like this. Okay, so if we get a too small error, we return a 10. If we get any other error, we return that error. Okay, it makes sense. So we can do a catch, and then it has like a, oh, I want to say pattern match, but it's like a lambda function. Okay. So it's like catch. Huh. You know what? I mean, yeah, because it makes sense to have this as a snippet. Probably this is like a really common pattern. but let's keep it with so it's like error, right? Oh, and I mean I like the fact that it errors on unused things. Like I like, honestly, having everything as an error and not having warnings, I think it's better, but I don't know if you have warnings in Zig. Okay, so yeah, let's keep it with if else at first, even though I saw like a spoiler that you can do it with. So it's my number error too small, so we return a 10, right? And otherwise we return error. And I'm guessing the return is going to be part of this lambda function, although I'm not sure if it's called lambda. Ah, yeah, I could have just seen this one and copied it, but yeah. Yeah, okay. I mean, yeah, it looks exactly as the, okay, yeah. So 25, 25. Let's see from the beginning. So yeah, try, as I said, I mean, try is pretty cool, but so it's here is the problem, right? Because detect can return an error or something that works, and you can use try to propagate the error. And here is the thing that I said, try is much more visible than doing it like this in Rust. I'm curious, if I do it like this, is it gonna say that's how I do it in Rust? No. Okay. But yeah, I mean, as I said, this one makes it more visible. I mean, since it's yellow, like, I mean, yellow for me, but since it's highlighted, maybe it makes it visible, but still prefer the words than symbols. Maybe it's gonna be like a cool challenge for me to try APL, or what's the language with symbols, since I like the words better. Would be like insane challenge. Okay, so it worked. 0.26. Hello. Yeah, I mean, already know about this stuff because so it can fail. So I just have to try to do it. Wait, what? Oh, so it's for the other one. I mean, in a weird way. Wait. Yeah, I mean, it's, probably like it's the like the language is still in development, right? So that's why we don't really have good LSP. Like, it doesn't show the error here, but it's like fine, whatever. 0.27. So defer. This one is good because it's like in Go. Nice. I mean, this is just an example, but this makes memory allocation and freeing a bit more easier to handle, right? Because usually when I do it in C, I have to go to the beginning, I see the malloc, I go to the end of the function, I do the free, but I saw, you know, from coding, I guess, the return defer pattern, and that one was pretty cool, whatever, and I started to use that in C, which, you know, makes sense. Okay, so let's see if it actually worked. Nice. Another one with defer, interesting. Oh, huh. So it prints something like this, and we want to, oh no, we want to print like this, and it prints like this. Interesting. So it wouldn't really work to say here defer, would it? Wait, what? I mean, yeah, whatever. Okay, this one sounds interesting because it's like with errors. Huh. Oh, error wait, this one is pretty cool. So, huh. It's like, yeah, it would be nice. Yeah, this one sounds nice because it's like, it's gonna print the message only when we have errors, right? Which I think, yeah, makes sense. Yeah, like this is a, you know, gave me an idea for the C library that I was doing, to have like something like this in there that you can use to print an error message and then but I mean, you know, that doesn't matter. Pretty cool though. I could fail, but I don't. Okay, so also has a switch 013. Yeah, like this was the pattern. So yeah, this one's pretty standard. Must be exhaustive. That's nice. Right, it's gonna switch must handle all possibilities. Yeah, it's really, but I mean, you know, integers don't really have infinite values, but also it's like else. Else std debug print question mark. Cool. I mean, sure, why not? It's just gonna be a exclamation point. Okay, so yeah, again, like having like all instructions as expressions, really like that. But I'm curious, like for the if statement, you know, if you can have more complicated stuff inside. C forces print. Oh, can you guess what happens when you remove the C? Wait, what? I mean, I want to see what happens if I do it like this. So it's like Zig exclamation point. Okay, and what happens if I it's numbers? Oh, because it's a new 8. Yeah, it's a new 8. Okay, didn't even notice it, but yeah, it's obvious. It's U8. Okay, nice. Unreachable. Yeah. So in this case, enums are gonna come in handy, I guess. So we want to say else unreachable. Yeah, and also unreachable keyword. So pretty cool. Because in C I would do something like assert false unreachable, right? Like this, or something like that. 033. If error. Yo. Okay, I mean, so far the exercise is neat, but at the same time would like to see where this would be used, right? Because it sounds pretty cool. So it's like, I guess, if foo is a value and if foo is an error, right? So this is how you do a try catch. Yeah, I mean, pretty standard stuff. So it's like if n is value, but how does it know that we talk? Maybe it's just like if, then it gives you the thing, and otherwise on the errors branch it's always error, regardless if you say some name like this or error, I guess. Okay, my number too small. Okay. Another quiz. Nice. So in this one, just be sure the output is, well, I'm just kidding. Wait, I mean it. Okay, so not change this one, right? Wait, am I wrong with something? I like if false. Yeah. I mean, I just have to say try, right? Function cannot return an error. Expected type void. Wait, am I missing something? Wasn't it supposed to be try? It's because main should be like this. Well, if we don't want to change the type of main, oops, then we can even do something like catch 0, right? So it's like still works, or what? Still uses try. Okay, so then the only way to do it is like this. Okay, so now we get into enums, which, I mean, you know, errors are kind of enums in a way. So let's see if we can have ink pow deck. These are the variants I can see. And yeah, we don't need an else because, as we saw earlier, it's like exhaustive, and since we have only 3 like constructors, I'm gonna say, because, you know, from Haskell world, or variants, we don't need the else. Interesting. So, you know, makes sense. This one, yeah, why not? So blue, is it RGB? So again, yeah, multi-line strings, they are really cool. And for this one, what does this thing mean? So X is lowercase hexadecimal. Okay, makes sense. Separator, whatever. Padding, alignment, width. Yeah, I mean, I would have never guessed, but yeah, whatever. Different than what I'm used to, but yeah. Okay, cool. Glorp the wise. Let's see some structures. So yeah, I mean, pretty standard. Like, this looks exactly like C, right? Okay, so this is a point, right? Okay, so we have an enum for the role. Pretty standard so far. Initializes glorp, makes sense. So added, oh, so we don't, but yeah, so we just want to add a new property. I was like, do we want to replace experience with health? Make it a U8 type. Okay, U8, there you have it. Health is gonna be 100. Okay, that's what it says. Very interesting. Oh, it's this one worked. I was like, did I do something wrong? 38. Zamp the loud. Oh, let's see, because this one is like, we have 2 of them. The second, oh my god, undefined. I mean, I guess if it's undefined, it's just like doing the C version of not initializing something, so it's like random values. But I really hate the word undefined. It's I mean, I would prefer not to have it at all than have it undefined. Whatever, it is what it is. So let's initialize. We already saw what happened. It's like because of undefined. Undefined strikes again, I guess. But at least in this language, at least it has the meaning that you would expect, right? So it's like random values. And so the role is gonna be bard. Simple. 10 health points and experience 20. Okay. And yeah, like the stuff. Garbage values. Oh. Oh, I mean, yeah, actually, yeah, it makes sense. That's pretty nice. 0xAA. Because it's, yeah, like it happened. I mean, I'm pretty sure it happened to me quite a lot in the compiler in C project to forget to initialize variables, right? And they were undefined, but since they have random values instead of this, it was much harder to debug. But we still have valgrind or tools like that which help, and it literally tells you the line where you have an undefined variable if it's being used. So, but this one, yeah, pretty nice. I mean, it's, if you debug the code, I don't know if Zig has a debugger, but if you go line by line and you see in your variable a, then you're like, okay, it's yeah, obvious. Nice. Pointers. Oh shit. Yeah, I mean, best definition, it's a reference. I mean, you know, my definition was it's a number, but it's an index in memory, in the memory array. In this example, whatever. I mean, I already know what pointers are, so dereferencing, yeah, this one was interesting. So this is like the type of a pointer, this is how you take a reference, and this is how you dereference. Yeah. So we have the following stuff. Number 1 is 5. Then we have a pointer to number 1. Number 2 is going to be undefined, so here we want to do what? Dereference num1 pointer dot star. I mean, yeah, maybe it's the reason why they did it like this is because people maybe get confused by the C way of dereferencing stuff. They are like, wait, star isn't it to make a pointer? Then yeah, like it, you know, it's weird. Maybe people are being confused, like star is for creating a pointer, so why do you dereference using a star? But yeah, maybe that's the confusing aspect. Okay, let's go to 40. Yo. Okay, so I mean, yeah, you can always make a const pointer to a mutable value, but you cannot make a var pointer. Yeah, I mean, it makes sense, but it just means that once data is declared immutable, you cannot make it mutable. fix this. What? Wait, why doesn't it work though? Because you need to say constituate, right? Yeah, right. 41. Define pointer p so that it can point to either foo or bar. And can change the value it points to. So clearly I think it needs to be var and can be like a pointer to constituate, right? U8, because we don't wait. And change the value it points to. Yeah, right. Like if you have a var pointer, it means that you can change the value of p, right? Not the value that's inside of the pointer. And if it's const, then you cannot change that thing. And this is the type of the value inside, so if you can change it or not. Right, so it's the same thing as with the normal variables, right? If it's const, you cannot change it. If it's var, you can change it. So yeah. But wait, I don't understand. Here we want to change foo and bar, right? So then we have to use wait pointer like that. Okay, 42. So I guess function calling. Yeah, so right, we want to change the value of x, so I mean that's like C basically. 43. So print character, it wants a pointer. So let's pass glorp. I mean, you just need to pass the reference to it. So yeah. Oh, the quiz. Okay, let's try to do the quiz. Oh, it's a linked list. Nice. Wait, is it true? I mean, probably. I don't know. I'm not an elephant. Please add elephant B. Okay, let's do that. Copy the line elephant AB. And we want to do something like right, so tail of A is gonna be B, tail of B is gonna be C. This one's fine. Yeah. Okay. Makes sense. Yeah, I think yeah, I mean so far, you know, the syntax is pretty simple. And what I think I liked, like the new feature that why I was like, whoa, is this error defer, which is pretty cool. Like it's only executed in case you get an error, That's nice. And I can see it being useful. And I guess maybe if error, but I still think that even how you do it in Rust is easy. So yeah. Whoa, what? The end. I mean, I think we can do like maybe another one with the rest of the stuff. Oh, new features for for loops, but let's not get spoilers. So yeah, I think I'll try to do another one of these, trying to solve more stuff. But yeah, I mean, so far it's like it feels like an improvement over C, like with a lot of quality of life things. But I don't get the idea of you have to program like in Zig, not like in C. I don't know what's the... Not sure. Maybe with the later examples we'll see that. Oh, really interesting about threading. But yeah, I mean, yeah, so far I see some improvements, quality of life. But again, like, would someone with a lot of experience in C be convinced to switch to Zig? I don't know. Like, maybe just make a toy project and explore it, see what the hype is about, and then go back to C. Probably that's what's gonna happen most of the time, but yeah. Like, I mean, probably I said the same thing about Rust, and then I was like, oh, yeah, why not just sometimes a language might be better for a certain project, so maybe that's the same with Zig. But yeah, I'd really like to, if you have any idea of what Zig would be best for, you can comment down below. Give me an idea for like a Zig project. What would it be good for? Like, would it be able to run on an Arduino? I'm curious about that, like, because it has custom memory allocators, right? I know about that. I don't see anything about memory allocators in Ziglings, so I'm not sure if that's being explained in here, but I know about that, so I'm pretty sure you can make it really easy to run it on embedded. So I'm curious about that. So yeah, let me know if you think about any cool projects for Zig, and see you in the next one.